Today I'm going to be talking about these things right here. So these are the basic circuit schematic symbols. Here I'm starting with a capacitor. And the capacitor can hold and release energy in an electric field. So a capacitor can be used to charge up, so you charge up when the voltage is high and then you discharge it when the voltage is low. So this can be used in power filtering and rectification to smooth out the output, and in audio and the LED like I just showed you. It can be used as a timer based on how fast it charges. Second, the resistor. I got right here some resistive nichrome wire. This is what happens when I put a voltage through it with my power supply. So yeah, this can be used to heat up, and it heats up because it wants to slow down the current. It can change the current draw on a circuit. You can add it in series with your LED to lower the current with the LED. Then we have an inductor can be something like this, and a transformer can be something like this. An inductor is used in the most famous circuit for it is the ZVS, because it can be used to block the AC power. An inductor can also be used to resonate, so we have an inductor. And a transformer is used to step up an AC voltage. I have here a broken ferrite transformer, and that's an iron core transformer, and this is a small ferrite transformer. This is a simple switch like this, and this is a MOSFET. This is an electronic switch. You can give some power here and control the voltage and current across here. Let's give an example. Right here I put it in a pretty small circuit just to turn on LED. As an electronic switch, when I put it to 2 volts, it turns on. And you can use the MOSFET as a switch. So now I'm tapping the gate, and when you charge the gate, it allows current to flow between the drain and the source. Now I've tied the drain to the gate because I need the same voltage. If I need a higher voltage, I would have fed it off a different power supply. And the source is ground, and I can use it as a small switch. This is a breadboard, these are the wires, and this is a LED. Now I have here a BJT, which is basically just a transistor but smaller, and used in different applications. So this can be used for a huge amount of power. You can use that for tens of amps, and this small transistor could be used for like milliamps, and could be used for audio. This is a potentiometer, which is a resistor, but it changes its resistance by using a graphite slider, which is in here, and then you slide a piece of copper on it, and that changes the resistance. This is a motor. A basic motor in a switch would be this fan extractor. This is a connector. So yeah, this is what the motor can do. We have here a relay. I have one right here, and as you can see, it has a coil, and that coil is basically an electromagnet. It's an inductor, and then it has this pin right here. You see this pin, and when I put in a voltage through it, the electromagnet takes the pin down and disconnects it from normally closed to normally open, connects it to normally open. So it's basically a mechanical switch that you operate with an electromagnet, and you can see it clicks. Now, this is a regular diode. This allows current to flow only in one direction. This is a Zener diode, and this can be used for limiting voltages or just making a simple voltage converter to get a lower voltage. Now, this is a Schottky diode. The schematic is simpler than what I draw here, but I recommend whenever drawing schematics, draw a Schottky diode like this. People will still understand it as a Schottky diode, but you won't confuse it to the Zener. This is a spark gap. So you can use a spark gap as a switch for high voltages. When a voltage goes over the spark gap voltage limit, like this, when a voltage surpasses, let's say, a few kilovolts, an arc goes here, it arcs across this, and turns the circuit on. This is a regular Schottky diode, it's very big, and these are some Zener diodes, usually glass body. From then on, we have the humble LED, which I switched right here, and then we have a variable resistor based on the light. You can use this circuit to detect movement and detect people. When people get in the way of this LED, the resistance changes. And then we have this right here. Now this emits light. This is basically the nichrome wire we did earlier, and this can be a lamp. This is a lamp. This is what's inside the lamp. Inside the lamp there's the tungsten filament, just like the nichrome wire I showed you. That glows up, it releases energy as photons. Now this is a battery. It's a small coin cell battery that I have right here. I really don't like the schematic. I don't like drawing batteries because I think you should usually just draw a power supply And this is a way simpler circuit than the battery, because you don't mix it up with a capacitor, with our depolarized capacitor. So I just like drawing power supplies even when I use the battery. Now I have a fuse right here, and this is impedance. How is this different than resistance? Well, impedance is actually capacitance, resistance, and inductance. Impedance can be used in AC or DC circuits, and impedance just gives a resistance, an AC resistance, which can be made from a resistance, capacitance, or inductance. Just like I told you, you could use an inductor earlier to limit AC current. Here we have a polarized capacitor and an AC source. Then we have ground. This is the ground schematic, and this is 5 volts. This is a simple voltage converter that will take your 10 volts to 5 volts. And this is an op amp and an inverter. Here is a 555 chip. This is a chip with all the pins labeled. Usually on the 555 there's a notch right here. The dot, this indicates pin 1, pin 1, 2, 3, 4, 5, 6, 7, 8, and it goes like this: 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. Here we have an amp meter, a voltmeter, and an ohm meter. Here we have a crystal oscillator, antenna, and a node, a circuit node. Basically, when you have two wires, like right here, when I want to show these two wires are connected, I don't just draw the wires, I draw a node if I have 3 or more wires to show that the wires are connected. Here we have a transformer. This is a ferrite core, this is air, and if you draw only one line, it's an iron core. And here we flip to the other side. We have the standard vacuum tube stuff, which is an anode, grid, some cathode, and here we have some simple circuits we could design. We have an AC source, then a transformer steps down the voltage, then diodes that allow current to flow in one direction in a circuit called a full bridge rectifier, which I have a video on, rectifies that, smooths it with the capacitor, smooths it again with the inductor, and also make sure you have real power. Then we use a voltage regulator and 2 capacitors to smooth out the output. Then we use a light variable resistor and an LED. Also right here you can charge a battery. Here's a very simple circuit. You have an LED, a resistor, and a capacitor. Now this capacitor will hold energy, and when the circuit is closed, when you take out the power supply, the LED will still be on for a couple of seconds, and the resistor is there to make sure the LED doesn't die. Now I'll go over everything quicker. This is a capacitor, this is a resistor, this is a inductor, this is a inductor, this is a transformer, switch, MOSFET, which is an electronic switch, transistor, which is an electronic switch. MOSFET comes from metal oxide semiconductor field effect transistor. Here we have a potentiometer, a motor, a relay, which is an electronically controlled switch but it's mechanical, a diode, a Zener diode, Schottky diode, spark gap, light emitting diode, light emitting resistor, light sensitive resistor, a battery, a DC voltage source, a fuse, AC impedance. You can use this as resistance and just write the resistance on it. Capacitor polarized, AC voltage source, ground, 5 volts, the voltage converter, comparator, op amp, and an inverter, 555 timer, ammeter, voltmeter, ohm meter, crystal oscillator, antenna, node, wire node, ferrite transformer, air transformer would be if it didn't have any line, and then iron transformer if it has one line. Now this is a circuit that uses most of the parts we have there, except something new. This is an IGBT. It's a cross between a transistor and a MOSFET. We use resistors, capacitors, 555 timer, more capacitors, the ground, diodes, and many more things. This is used to generate a high voltage and the transformer secondary. And now I'll show you how to actually use a MOSFET. Now, almost every MOSFET is gate, drain, source. You can learn it as good day sir. So if you can learn good day sir, you know, gate, drain, source. And then put the ground right here. Source is always ground, because if not, you will kill the inner diode of the MOSFET. And now I can use this as a switch. I can still power this on. You should add a resistor. I'm doing something very bad. You should add a resistor to the gate. First of all, to the gate to source, and also add a resistor after the LED, because you're basically killing the LED at 5 volts. Let's see, what if I drive it? Will it turn on at 3 volts? Still turns on. 2 volts? Doesn't turn on, because that's the turn on voltage for the MOSFET. The diode still won't turn on. Don't heat the batteries. Capacitors are nice, but don't touch them. Inductors can generate high voltage, don't touch a relay while it's switching. And resistors can heat up and burn you. Also, don't play with high voltage. Just don't.